Welcome to Mimi's Math Channel. Today I'm going to talk about arithmetic sequences. As you can see, these are the different types of formulas that we will actually be working with. So we have explicit formula, which is a sub n equals a sub 1 plus d times the quantity of n minus 1. Or sometimes it's better to write it in the form of a sub n is equal to d times the quantity of n minus 1 plus a sub 1. So all I'm doing is just reordering the formula. On the recursive formula, I have a sub n is equal to a sub n minus 1 plus d. Now, on the first one, I identified your a sub n is the n represents your nth term, a sub 1 represents your initial first term, and d represents your common difference. It's the same over here in the recursive formula as well. The only difference is the a sub n minus 1 represents our previous term. So all you're doing is adding d to the previous term in that formula. Your explicit formula, if you actually distribute this out, you can end up going to your linear function. Your linear function is very helpful when you're trying to graph. You've learned this before. This is when you have like your slope as your m, and then b is your y-intercept. So if you don't have this information in your notes, go ahead and put that in your notes. And let's go ahead and get started. So the first thing we're asked is to determine whether or not the sequence is arithmetic. And in order to determine that, you need to know whether or not there is a common difference. The common difference can be found by either adding to see if I'm adding the same number each time or going backwards and subtracting. So for instance, for number 1, -4 plus 5 would give me 1. 1 plus 5 would give me 6. 6 plus 5 is 11. 11 plus 5 is 16. So therefore, since I have the common difference, that means that I am actually dealing with an arithmetic sequence. So D in this case would be 5. And my A1 would be the initial term that's shown there, which is -4. For example 2, we are asked to create an equation to represent the following pattern. So given the visual representation, I am going to count each set of blocks. So here I have 3, and it looks like I added 4 more, and it looks like I still added 4 more. So that's the best way to do it, is just count the actual blocks and then write what you have. So I have 3, and then I added 4, so that's going to be 7. I added 4 more, so that's 11. My explicit formula, as you saw in the beginning, would be created based off of what I know as far as my a sub 1 and my d. So if I wrote it the original way, my a sub 1 is 3, and then I have plus 4 times the quantity of n minus 1. Again, this is my a sub 1, and the 4 represents my d, my common difference. I could have written it the other way where the d comes first, so then I would have a sub n is equal to 4 times the quantity of n minus 1 plus 3. Either way would work. From that, I can distribute to find the linear function. So if I were to take this 4 and distribute it, that would lead me to my linear function, which is going to be, this time I want to use f of x. F of x is equal to, and I'm going to change that n to an x since I'm using f of x. So then I would have 4 times x minus 4 plus 3. Well, what I noticed is I can combine those like terms. So now the recursive formula would be that a sub n is equal to a sub n minus 1, and take all of that and add it to the difference, which we know is plus 4. Example 3, represent the sequence -2, 1, 4, 7 using a formula and a graph. Similar to example 2, we will substitute what we know in each formula. So for the explicit formula, we know that a sub 1 is equal to 2, and in order to get to the next number in the sequence, we will add 3 each time. So remember, the plus 3 represents d in the formulas. So for your explicit formula, it's going to be a sub n equals -2 plus 3 times the quantity of n minus 1. Or if you write it in a different order, where the d is first, it will be a sub n is equal to 3 times the quantity of n minus 1 minus 2. When you distribute it, you will figure out your linear function. So we're going to go ahead and distribute the one that's shown here, and we will see that our linear function is going to be f of x. And again, we're going to change that n to an x. And then you should be able to see that you can combine those two like terms. All right, so we tend to use x since we may have to graph, and it's easier to identify the x since we know that we have an x-axis on the graph. Now, if we're talking about recursive formula, then it's going to be a sub n is equal to a sub n minus 1 plus 3. Because we knew the d, we could substitute that in. So I can use any number for that n and it would still work. So if I wanted to know the second term of my sequence, I would use the formula and then substitute 2n every time I saw the n. So again, just to show you, if I wanted to find 2, a sub 2 minus 1 plus 3, this really becomes 1, and I already know that a sub 1 was my first number, negative 2. So I'm just going to put that this is replaced with negative 2 plus 3. So therefore, I know that my second term should be 1. And if I look above, my second term is actually 1. You can do that for any term that you would like. All right, now graphically, what I want to do is I will personally go back to my linear function because this tells me my slope. 3 is going to be my rise, and it's over 1. It's understood to be over 1, which is my run. So rise over run, and negative 5 is my y-intercept. So this is what it would look like as a graph. So what I would do is I would initially start with my y-intercept, and then from that I would go up 3 because again my slope is 3 over 1 if you put it in fraction form, and my y-intercept, which is my b, is negative 5. So you're used to seeing it as y is equal to mx plus b. This is where this information is helpful. All right, so I went up 3 and then I ran over 1. And then you can go in the opposite direction as well. So 3 over 1 is the same as negative 3 divided by negative 1, which means now I'm going down 3 from my y-intercept and to the left 1. It still means the same thing. What you will notice is that you have formed a line. It's a linear function. All right, in the last example, example 4, you were given the first term and the common difference and asked to find a specific term. So if you're using an explicit formula and substituting, you would have a sub 12 is equal to 0.25 minus 1 times the quantity of 12 minus 1. So simplify what's in the parentheses instead of trying to distribute since these are like terms. Go ahead and do that first. But you're going to bring everything else down. So that's one way to do it. Or you could have rewrote the explicit formula with d first, and then you distribute it as a sub n is equal to negative 1 times the quantity of n minus 1 plus 0.25. And now you would just distribute and continue simplifying. So when you get to this point, now you can substitute whatever term was given to you. In this example, it was 12. So I am going to replace my n's with 12. So every time I see an n, I'm going to replace it with a 12. And then I'm just going to follow the math operation. Thank you for watching. Please like and subscribe. Have an awesome day.
Subscribe.